Okay, so today is day one, solving exponentials and logs. So up until now, we've just been like simplifying them or dealing with expressions, but today we actually get to solve them. I'm working on getting all the videos onto YouTube so you can put on captions if you can't hear well. But I'll go back through and add YouTube links when that is done. Okay, so we just want to talk about like how can we solve these? So it turns out that there is a property of equality for both exponential and for logs. So basically it just says that if like 3 to the x is equal to 3 to the 5th, then x has to be 5. So I will write those down, but it's not life-changing for you guys. Because it turns out y'all have been looking at the property of equality in math over and over again. That's why whenever you solve equations, you have to do to one side what you do to the other. It's all for this equality property that exists. So basically, if you have 3 to the x and that is equal to 3 to the 5th, then you know that x has to be equal to 5. You know, incredible stuff there. So yeah. It does get more complicated than that because of course it does, it's math. But we'll just start with that. And then there's the property of equality for logs. Which states somewhat of the same. So if log 2 of x is equal to log base 2 of 7, then x equals 7. Great. Okay. The video here, not the video, the book here also like defines exponential equations and log equations, but I think we already know since we've been working with them for so long. So I'm just going to do an example. This one is not from your homework, but we'll do another one that is from your homework here in just a second. So if you have 100 to the x is equal to 1/10 x minus 3, we want to solve for x. So we're going to kind of culminate or put together everything that we've learned thus far about logs and exponentials and put them together to solve this equation here. So the first thing that we need to do is figure out how to get to these x's, right? So hopefully we see that 110 have something in common, right? I could rewrite this as 10 to the 2x. And then I could rewrite 1/10 as something, right? We just kind of want to think about what it is that we know about these numbers and what they have in common so that it's easier to solve. So I know that 1/10 is 10 to the negative 1. And so then I can just distribute that x minus 3 to the negative 1. So I have 10 to the 2x is equal to 10 to the minus x plus 3. And that's good there. Great. So now that I know how to get here, right? I can just take log base 10 of each side, right? And I can get to the x's that way because that's what the inverse is, right? So I'm going to take log of both sides, and so then I'll get 2x is equal to negative x plus 3, and then hopefully this part becomes very simple to you. You can add x to both sides, and you'll get 3x is equal to 3, so x is equal to 1. Beautiful. Okay, so let's do a log example, and then we'll go into your homework. So let's do natural log of 4x minus 7 is equal to natural log of x plus 5. And we know to get rid of the natural log, we need to raise it, have the e there, right? So those will cancel, and I'll just get 4x minus 7 is equal to x plus 5. And then we can work from there. So really the key to solving this is going to be to simplify here. When you can simplify or rewrite it so that the numbers match, so you have the same base for when you take the log. And knowing that e and natural log are inverse, just like the log and an exponential are inverse. The rest of that should be a bit more simple. Right? Hopefully the rest of this is exactly as you know algebra to be. Okay, so in the day 2, oh sorry, you can't see that. In solving logs day 2, we'll talk about inequalities, but until then, we'll just keep doing these, just solving with normal equal signs, no inequalities. So your homework was 5 through 15 and 21 through 39. I'm going to forget that. 5 through 15 and 21 through 39. So we'll just start working on some of those. So number 5 is simple to the one that I just did, similar to that one. Let's do 7 because you'll need to rewrite 7 a little bit. So you have already messed up. Okay. So you have 5x minus 3 is equal to 25x minus 5. So I'm going to rewrite this 25 to match my 5 here. That way I can use the same log base. So I'm going to say 5 squared x minus 5. Just making all sorts of mistakes here. So 5x minus 3 is equal to 5, and then 2x minus 10. So I just distributed those together. Okay, so then you can take the log of both sides with the base 5, and those cancel and those cancel, so you're just left with x minus 3 equals 2x minus 10. So plus 10 minus x, 7 equals x. And there you go. $15, I think you can do $13. We'll think about that. 11 is just like the example I did, the first one. So we'll do that. Okay, and then 21, 22. Which one looks difficult? None of them right now. Let's do 25. So you have log base 2 of 4x plus 8 is equal to 5. So remember to cancel, you have to use the same base. So I'm going to say 2 and 2. So you'll have 4x plus 8 is equal to 2 to the 5th. Yeah. Did I do one of those? I did the natural log. Okay. So 4x plus 8, 2 to the 5th is 32. So subtract 8. 24. So x is equal to 6. Perfect. Yeah, I think that's fine. I think we're doing great. Notice that in 33 through 40, it says solve the equation and check for an extraneous solution. So please make sure you are checking for your extraneous solutions. Great. Honestly, I think that's good. If you've got questions, let me know in class, but that should be enough examples to get you through. You just got to remember what your inverses are. If you don't remember that, what was that? 7.4? No, 7.3 was your inverses. 7.4 was all your transformations. So yeah, go back to 7.3. Look at your inverses. You'll be great.